In this experiment, a polyprotic phosphoric acid will be prepared by running a solution of sodium polyphosphate through an acidified cation exchange column. The free polyprotic phosphoric acid is then titrated with a standard sodium hydroxide solution in order to determine how many proton ions were replaced by sodium ions. Thereafter, we can determine the average chain length of the PPA. In this part of the experiment, the sodium DOX column will be acidified by passing a concentrated solution of HCl through it. This will result in an exchange of sodium plus ions from the column by H plus ions from the HCl. To start with, we need to acidify our sodium DOX column. First, we lower the water level down to just above the resin level. Be careful never to let the water level or liquid level below the resin level. Then we will measure 150 ml of 2 molar HCl using a measuring cylinder, transferring the excess into the beaker. Remember to check the meniscus by having your measuring cylinder at eye level. Then we measure the remaining 50 ml. Using a funnel, we are going to transfer the 150 ml of HCl into the column. And then open the tap. You can have the tap open continuously. Just remember to never let your acid level go below the resin level. We keep adding until the entire 150 ml passes through the column. Once all the HCl has been passed through the column, we need to wash out all the excess acid with deionized water. We'll open the tap and keep the water running while we're adding at the reservoir. Again, remember to keep your water level above the resin level at all times. You need to do this using at least 500 ml of water. Thereafter, you can close your column. Then collect some of the liquid from the column in a new clean vial. We're going to add some silver nitrate in here so that we check if all the HCl has been washed out. If all the HCl had been washed out, we would not have a murky color. The murky color is because silver is reacting with HCl to form insoluble silver chloride. So continue washing until when you add your silver nitrate to your solution, you don't see any murky color. In this part of the experiment, the acidified column is used to convert our sodium polyphosphate into PPA. This is done by running a solution of sodium polyphosphate very slowly through the acidified column. Once all the sodium polyphosphate is dissolved, we're going to transfer it into the column and let it percolate very slowly through. Then we will collect the PPA in a 250 ml beaker. It is important to do this very slowly so that there is enough time for the sodium proton cation exchange. Thereafter, we are going to wash down the excess with 50 ml of deionized water. In this part of the experiment, we are going to weigh to 4 decimal places about 200 milligram of the sodium polyphosphate. Then we will transfer it into a 100 ml beaker and then dissolve with 15 ml deionized water. Once all the sodium polyphosphate is in solution, we are going to perform the cation exchange part, where we transfer the solution into the column. At the end, we're going to collect in this beaker the polyphosphoric acid. It is important to collect the sodium polyphosphate solution very slowly. This allows for enough time for this. Okay. Okay. Once all the sodium polyphosphate is dissolved, we're going to transfer it into the column and collect the PPA very slowly in the 250 ml beaker. It is important to let the solution run through the column very slowly to allow enough time for the cation exchange part. In this part of the experiment, the free polyphosphoric acid is titrated with 0.2 molar sodium hydroxide. This will help us determine how many proton ions were exchanged by sodium ions from the sodium polyphosphate. Once we have collected all the free polyprotic phosphoric acid from the column into the beaker, we're going to add a stirrer bar in. Thereafter, we will calibrate our pH meter. Then we rinse a clean burette with the solution of sodium hydroxide. Then we'll fill it halfway or up to the comfortable eye level. Here we are going to first record the pH value of the PPA solution on its own. On the pH meter, it says 0.23. That already tells us that our PPA is indeed acidic. From this point on, we're going to titrate the PPA solution with a standard sodium hydroxide solution while recording the pH of the PPA. We need to keep the PPA solution stirring so that we can keep it homogenized for the stability of the pH values. Once we start the titration, you will see the pH values increase slightly to more basic. That's because we are adding the sodium hydroxide base to the PPA solution. Record the amount of sodium hydroxide added to each pH value. Once the first endpoint has been observed at a pH of 4 to 5, then continue titrating to see the second endpoint at a pH of about 7. The last pH endpoint at about a pH of 10 will not be very easy to see because the last anion, the phosphate, is too basic. So the equilibrium keeps shifting back and forth between the acidic and the basic. Thereafter, the solution goes more basic until a constant pH is achieved. This concludes the video on the determination of the average chain length of sodium polyphosphate.